OpenFlow tables. When a packet arrives at an OpenFlow switch, the processing pipeline begins with the lowest numbered table. Tables contain flow entries that have match fields, actions to take, and track statistics. The highest priority flow entry in a table that matches a packet is the one that will be used. The action might be to leave the processing pipeline. Example actions are sending out one or more ports, drop, flood, or send the packet to an OpenFlow controller in a packet in message. The action instead might be to send the packet to a different table numbered higher than the current one. For example, a packet might be processed by table 0, then table 1, then table 10, but you have to move forward through the table numbers. A good use of this processing pipeline would be to separate out logical functions. This is analogous to order of operations on traditional router interfaces. For example, a router may first check input firewall rules, then QoS parameters, followed by any NAT rules, and so on, going like that through different logical features before being sent out a destination interface. This diagram shows the topology for this video using Mininet network emulation. The OpenFlow switch is S1 and is Open vSwitch. H1 and H2 have IPs 10.0.0.1 and 10.0.0.2, so they are in the same subnet. H3 is in a separate subnet with IP 30.0.0.3. On H3 I'll start a port 80 web server. I'll launch Mininet with the MAC option so we get these simple MACs shown here. Also note the OpenFlow ports 1, 2, and 3, which will be used for our forwarding actions. This diagram shows how I'll set up flow tables on switch S1. When a packet arrives, first table 0 is checked, which I'm calling the access control table. In this table, I'll define rules similar to router access control lists. In the first flow entry, I'll permit ARP and IP between any 10.0.0.0/24 IPs. In the next flow entry, I'll permit H1 to reach H3 via ICMP or TCP port 80. Next, I'll allow any traffic from H3. For those three permits, the action will be the same, which is to continue on through the processing pipeline onto table 1. Finally, in table 0, there is the default drop, meaning any traffic that doesn't match the previous conditions will be dropped and of course not make it to table 1 for processing. For example, H2, which is at 10.0.0.2, will not be permitted to reach H3 because there is no explicit rule to allow that. Table 1 has NAT rules. When H1 connects to H3, I'll say that H1's source IP should be changed to 5.5.5.5 and to continue through the pipeline to table 2. For the return traffic, I'll say traffic to 5.5.5 from H3 should be natted back to 10.0.0.1, also with an action to go to table 2. Then there will be a default rule for any other packets not matching these first two rules just to go to table 2. So unlike the access control table, by default we can continue on in the processing pipeline. In this last table, I'm setting simple rules so hosts can reach one another, even on different subnets. This will be done by matching on the destination IP address and using that to set the proper destination MAC address. What I'll do to my hosts so this can work is I'll give them a dummy default gateway and a dummy ARP entry to reach the default gateway. This will keep my host from sending out ARP requests for a default gateway. As long as a packet gets to my OpenFlow switch, I can manipulate it correctly to get to another host on a different subnet. This isn't dynamic or using a routing protocol as a traditional router would, but that functionality could be reproduced in an OpenFlow controller. Also in this table, I'll put rules for ARP between H1 and H2.